Hey, what's going on? Today we're building a VLAN setup in Packet Tracer. VLANs allows us to segment and network into different groups, improving security and efficiency. First, we'll add our router. This will serve as the gateway between VLANs, handling inter-VLAN routing and DHCP services. Now we're bringing two switches. One will have 6 PCs while the other will have 12. Each switch can support multiple VLANs, meaning we can have different network segments running on the same physical device. This is super useful for organizing networks in offices, schools, or any large environment. Next, we'll add our PCs. We'll have 18 PCs split into VLAN 10 and VLAN 20. VLAN 10 will represent the HR department and VLAN 20 will be the management department. Even though all these PCs are connected to the same switches, VLANs allows us to separate their traffic logically. Devices in VLAN 10 can only talk to other VLAN 10 devices unless we configure inter-VLAN routing, which we'll do later in this video. Now, here's something important. Keeping everything clean, organized, and labeled makes troubleshooting and management so much easier. Trust me, when you're working in a real environment, having clear VLAN assignments and properly labeled devices will save you a ton of headaches. So let's label everything properly now. Now let's wire all of the devices. Alright, with our topology set up, let's configure VLANs on our switches. First up is VLAN 10, which we'll name HR. This VLAN will be assigned to ports F0/1 to F0/3, the devices we labeled for VLAN 10. Alright, VLAN 10 is created and assigned to the correct ports. Now, let's move on to VLAN 20, which will handle the management department. The assigned ports for VLAN 20 are F0/4 to F0/6. Oh, looks like I forgot to create VLAN 20 first, but Cisco switches automatically create VLANs when you assign them to a port. However, it's always good practice to create and name your VLANs manually to keep everything organized. So let's name this VLAN now. There we go. VLAN 20 is now officially named management. Now, let's configure switch 2 and assign each port to their correct VLAN. Now that our VLANs are set up, we need to configure a trunk link between our switches so that VLAN traffic can pass between them. We'll do this on interface G0/2. Wait. Oh, I forgot. So before setting a port to trunk mode, I need to manually specify the encapsulation type. On some older Cisco switches, trunk ports can use either ISL or 802.1Q, which is the industry standard. But modern networks mostly use 802.1Q. Since my switch supports both ISL and 802.1Q, it needed me to specify .1Q before allowing trunk mode. Let's make sure it's good. Now we do the same configuration on the other switch. Now let's verify that our trunk link is active and passing VLAN traffic. Perfect, the trunk is up. Now that our switches are set up with VLANs and trunking, we need to configure the router to handle inter-VLAN communication. A router's physical interface can only have one IP address, but we can use sub-interfaces. We can create VLAN 10 and 20 on the same interface, but for this example, we'll create a sub-interface on G0/0 and another one on G0/1 for each VLAN, because I'll be making another video using this same layout. Here we created a sub-interface G0/0.10 for VLAN 10. The encapsulation .1Q10 commands tells the router that this sub-interface is handling traffic for VLAN 10. Then we assign it an IP address. (192.168.1.1), 255.255.255.0. That will act as the default gateway for all VLAN 10 devices. Now we configure G0/120 for VLAN 20, setting its encapsulation to .1Q and assigning it 10.1.1.255.255.255.0 as the default gateway for VLAN 20 devices. Now that our router sub-interfaces are set up, we need to make sure our switches can pass VLAN traffic to the router. To do this, we'll configure trunking on both switches' G0/1 interfaces. Here on switch 1, we first set the encapsulation to .1Q since some switches require this before allowing trunk mode. Then we enable trunk mode to allow VLAN traffic to pass through. Now we do the same thing on switch 2. Now, let's set up DHCP on our router so that all devices in VLAN 10 and VLAN 20 can automatically receive their IP addresses. Before we create the pools, we need to exclude the gateway IP addresses so they don't get assigned to any devices. Next, we create the pool and I'll name it VLAN 10. I assign the network address 192.168.1.0 with a subnet mask of 255.255.255.0. I'll set the default router to 192.168.1.1, which is our gateway for VLAN 10. Then I provide the Google DNS server at 8844. Now I do the same for VLAN 20. I'll name it VLAN 20. Set the network address the default router and again provide Google's DNS server. Let's check the status of both of our DHCP pools. Looks good. Both VLAN 10 and VLAN 20 pools are properly configured, and our devices should be able to get their IP addresses automatically when they connect. Next, we'll test the DHCP configuration by checking if the PCs are receiving IP addresses. As I click on the first PC, you can see that it is already set to DHCP and has automatically received an IP address. This confirms that our DHCP server and the trunk links between the switches are working correctly. Now, I'm going to change all other PCs from static IPs to DHCP. As I do this, you'll notice that each PC receives an IP address from the appropriate VLAN pool. You can see them all successfully receiving an IP address from the router's DHCP server. This confirms that the trunk links between the switches are passing the VLAN 10 and VLAN 20 traffic properly. Now, all the PCs across both switches have been set to DHCP, and they've all received their IP addresses correctly. So now that we got everything configured, let's test connectivity. First, I'm going to ping a PC in another VLAN from VLAN 10 to VLAN 20, which has the IP address 10.1.1.4. And look, the pin is successful. This confirms that the router is properly routing traffic between VLANs 10 and VLAN 20. The router sub interfaces for each VLAN are allowing communication between the two VLANs. Next, I'm going to test connectivity within VLAN 10, but this time between two PCs on two different switches. I'm pinging a PC with the IP address 10.1.1.8. And again, the pin is successful. This confirms that the trunk link between the two switches is allowing VLAN 10 traffic to pass properly, and both PCs can communicate despite being on separate switches. And that wraps up today's configuration. We successfully set up VLANs, routing, and DHCP for our network and verified that everything works as expected. If you have any question or if something wasn't clear, feel free to leave them in the comments below. Also, if you found this tutorial helpful, be sure to like and subscribe. Thanks for watching, and I'll see you in the next one.